Good morning, everybody. Good afternoon. I said good afternoon.
Good afternoon, sir.
Okay, so I think I'm audible to you all also. Okay, so yesterday, what all we have done, first of all, we understood about the Cartesian product of two sets. All right. Then we have done equality in ordered pairs. Then we have done the relations. Relations is what? It is a subset of Cartesian product A cross B. All right. Then few examples of relations, what is their domain, what is their range, and how to write a relation in roster form, set builder form, and arrow diagrams. Then we have done some examples of empty relation, universal relation, and also we have practiced one question from determinant from the matrices chapter, how to solve word problems using equations. Yes or no? So today the topic is very important, that is types of relations. All right. So this is the actual strength of this topic, from where generally long questions are being asked. Am I clear? Before that, I would like to repeat one more thing. See, if a relation is defined on set A, what does it mean? If a relation is defined on set A, that means relation is a subset of what? Tell me.
A cross A.
A cross A. This is what yesterday I have told you. A cross A. Now, if a relation is defined on set A, we classify the relations into three categories. The relation can be reflexive relation. First of all, the term comes reflexive relation. The relation can be a reflexive relation. So, what is a reflexive relation? A relation R on set A is called reflexive if A comma A belongs to R for every A belongs to A. Means whatever the elements are there in A, if A cross A, every element is related to itself. If A cross A is related to itself, then we call it a reflexive relation. Understood? Each element should be related to itself. Each element should be related to itself. Am I clear? For example, like you have a set A as 1, 2, 3. Now I defined a relation that is having elements 1, 1, 2, 2, and 3, 3. Now tell me, is it reflexive or not? Is this relation a reflexive relation? Tell me quickly.
No, sir.
Yes, it is reflexive. If I define a relation R2 as 1, 1, 2, 2, 3, 3, 1, 2, 2, 1. Is it reflexive?
Yes, sir.
Yes, this is also reflexive. If I define a relation R3 as 1, 1, 3, 3, 2, 3, is it reflexive?
No, sir.
Not reflexive. Why so? Because 2, 2 is not in R3. every element should be related to itself. Am I clear? Now, if you remember, yesterday I taught you something that is identity relation. What is there? If every element of set A is related to itself only, we call it identity relation. Now tell me, what is the difference in identity relation, identity relation, and reflexive relation? Yes, what is the difference in these two? Anybody? See, in identity relation, every element should be related to itself only. Like there should be 1, 1, 2, 2, 3, 3 only. And here, every element should be related to itself. Getting my point? Here, only word is not there. So like if I see above the above relations, this R1, R1 is reflexive as well as identity relation. But R2 is only reflexive, not identity relation. Am I clear? Tell me if you understood or not. Have you guys got it? Identity relation, in identity relation, element should be related to itself only. There should not be any 2, 3, 3, 2, 5, 2, 5, 3. It should not be there. Only 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. That kind of relation should be there. That is what we call identity relation. Reflexive में 1, 1, 2, 2, 3, 3, 4, 4 तो चाहिए. But along with it, it can be 1, 2, 2, 1, 1, 3, 2, 1, 3, 3, 2. Other elements can also be there. Am I clear? Am I clear?
Yes, sir.
Now there comes symmetric relation. Symmetric relation. Now, what is a symmetric relation? A relation on set A relation on set A is called symmetric. Is called symmetric if A comma B belongs to R, then B comma A should also belong to R. If A comma B belongs to R, then B comma A should also belong to R, where A comma B belongs to set A. Understood? Like if there is a 2, 3 in the relation, there should be 3, 2 also. If there is 1, 3 in the relation, there should be 3, 1 also to make the relation symmetric. For example, over the set A, 1, 2, 3. Let a relation R1 is defined as 1, 1, 2, 2, 1, 2, 2, 1. Is it symmetric? Tell me.
Yes, sir.
Yes, there is a 1, 2, then there is a 2, 1 also. Is it reflexive?
Yes.
No, because 3, 3 is not there. Now R2 is 1, 1, 2, 2, 3, 3, 1, 2, 2, 1, 2, 3. That's it. Now, is it symmetric?
No,
No,
sir.
sir.
Tell me, is it symmetric or not?
No, sir.
No. Why no? Because 2, 3 is there, but 3,
3 to 9.
2 is not there. Understood? With respect to 1 to 2, 1 is there, but we will look for the shortcomings. We will look for the issues, not for the, I should say, not for things which are there. We will look for things which are not there. Like 1 to 2, 1 there, that's fine. But 2, 3 is there, 3, 2 is not there, so it is not symmetric. Is it reflexive?
Yes, sir.
Yes, sir.
If I write R3, that is 1, 1, 2, 2, 3, 3. Now tell me, is it symmetric?
Yes, sir.
Yes, very good. Because if 1, 2 is there, I will look for 2, 1. If 2, 3 is there, I look for 3, 2. But if there is nothing like that, then we will consider it symmetric by default. Agreed? Say I write another R4, that is 1, 1 and 2, 2. Tell me, is it symmetric?
No,
Yes,
yes,
sir.
sir.
Yes. This is also symmetric. Is it reflexive? No.
No,
Is
sir.
it reflexive? Yes. Understood?
Yes, sir.
Then there comes a third type of these relations, that is transitive relation. There is a third kind of relation, that is transitive. So a relation R on set A is called transitive if, say, A comma B belongs to R and B comma C also belong to R. Then A comma C should also belong to R to make it transitive. If AB and BC is there, then A comma C should also be there to make it transitive. Am I clear?
Yes, sir.
If AB belongs to R, BC belongs to R, then A comma C should also belong to R to make it transitive. Like, take an example. Over the set A, 1, 2, 3. You define a relation R1 as 1, 2, 2, 3, 1, 3. Is it reflexive?
No,
Tell me
sir.
quickly. Is it reflexive?
No, sir.
Reflexive? No. Is it symmetric?
No, sir.
No. Is it transitive?
Yes, sir.
Yes. 1, 2, 2, 3 is there, then 1, 3 is there. Next, if I define R2, that is simply 1, 2. Now tell me, is it reflexive? No.
No, sir.
Is it symmetric?
No, sir.
No. Is it transitive?
No, sir.
Yes, it will be. What did I tell you in the definition? If 1, 2 and 2, 3 are there, then we will look for 1, 3. Agreed? If 1, 2 and 2, 3 are there, then we will look for 1, 3 and we'll call it transitive or non-transitive. If only 1, 2 is there, there is no other element like 2, 3, then it is by default transitive. Got my point?
Yes, sir.
Now say I have a relation 1, 2, 2, 1. Is it reflexive?
No, sir.
No. Is it symmetric?
Yes, sir.
Yes. Is it transitive?
Yes.
Transitive?
No, sir.
No. Because 1, 2, 2, 1 is here, 1, 1 is not. 2, 1, 1, 2 is there, 2, 2 is not there. So this relation is not going to be transitive. Am I clear? Am I clear?
Yes, sir.
Yes, sir. Yes.
Now, there is a very important point. If a relation is reflexive, symmetric, and transitive all, then we call it equivalence relation. If a relation is reflexive, symmetric, as well as transitive, then we call it equivalence relation. Am I clear? Have you got my point? If a relation is reflexive, symmetric, and transitive all, then we call it equivalence relation. Clear? Are you clear about equivalence relation?
Yes, sir.
Yes, sir.
Then we call it equivalence relation. Fine. Now, let us write down few relations and understand how to write them in the exam copies, or how do we manage with them. Like a relation R, write down a question. A relation R is defined on the set of natural numbers and defined as R is A comma B such that AB belongs to natural number and A minus B mod is even. R1, R2 is A comma B, AB belongs to natural number and A divides B. This means A divides B. A divides. Okay. Comment if R1 and R2 are equivalence or not. First of all, you got the question. Now let's begin with the solution. First of all, I'll talk about R1. First of all, I'll talk about R1. Now, reflexive. Let A is related to A. That means A minus A mod, which is 0, is even. Yes or no? That means A comma A belongs to relation for every A which belongs to the set of natural numbers. Because every natural number, if it is subtracted to itself, what do you get? 0, which is considered as an even number. So that means every element is related to itself. So a relation is reflexive. Am I clear or not? Are we clear about it?
Yes, sir.
Yes, sir.
Now, let's come to symmetric. Now, see it very particularly. How do we write it? Let A comma B belongs to R. Means A comma B belongs to relation. This implies A minus B magnitude is even, yes or no? This implies B minus A magnitude is also going to be even. This implies B is related to A. Tell me, if A comma B is there in the relation, then B comma A should also be there in the relation because B minus A mod is also going to be even. Implies what? Relation is symmetric. Am I clear? Tell me. Now let's come to transitive. Now, what is there? Okay, again, Dhanush is asking. Dhanush, let us assume that A comma B belongs to relation. Dhanush,
Sir.
do I pronounce your name correctly?
Yes, sir.
Dhanush or Tanush?
Tanush.
Tanush. Okay. So let us assume that A comma B belongs to relation. That means magnitude of A minus B is going to be even.
Yes, sir.
Now, if A minus B mod is even, then B minus A mod is also even. Like you see, 2 minus 6 mod is what? 4. Then 6 minus 2 mod is also 4, no?
Yes, sir.
So that means B minus A mod is also even. That means B is also related to A. You assumed A, B belongs to R. You proved B, A also belongs to R. That means what? Relation is symmetric.
Symmetric.
Am I clear?
Yes, sir.
Now, transitive. Transitive will start with assuming that A comma B and B comma C belong to relation. Let A comma B belongs to R and B comma C also belong to R. This implies A minus B mod is even and B minus C mod is also even. This implies A minus B is something like 2K1 and B minus C is something like 2K2. Yes or no? This implies if I add both of them, what do I get? A minus C is twice of K1 plus K2. That means A minus C is also even. That means A minus C mod is also even. That means A is related to C. And that means A comma C belongs to R. Have a look at it. See, how did I explain it? This explanation and the way of explaining is also very, very important. AB belongs to R and BC belongs to R. So A minus B mod is even and B minus C mod is even. That means A minus B is 2K1 and B minus C is 2K2. So if you add both of them, what do you get? A minus C. A minus C is what? Twice of K1 minus K2. Twice of K1 plus K2, which is also even. So A minus C mod is even. So A is also related to C. Am I clear? So that means a relation is transitive. So if a relation is reflexive, symmetric, and transitive, means it is an equivalence relation. So the relation is reflexive, symmetric, and transitive. It is an equivalence relation. Am I clear?
Yes, sir.
So this is a way of writing these things. Correct? Am I clear?
Yes, sir.
Now, there was a relation R2 also, A comma B belongs to N and A divides B. So, R2 is a relation that is A comma B. AB belongs to natural number and A divides B. Now tell me, give it a thought, write it down for 1 minute, 2 minutes, tell me what it is. Is it reflexive? Writing is secondary.
Yes,
First
sir.
of all,
Reflect.
let us be sure on our own. Is it reflexive?
Yes, sir.
Because every element divides itself. Yes or no? Now, is it symmetric? Tell me.
No, sir.
Sorry. Is it symmetric?
No.
No. Because if A divides B, then B will not divide A unless A is equal to B. Like 2 divides 4, but 4 does not divide 2. Fair enough?
Yes, sir.
Now, third point. Transitive. Is it going to be transitive? Tell me quickly.
Yes, sir.
Yes. Because if A divides B and B divides C, then A will certainly divide C. Fine. So, how do I write it? First of all, reflexive. So, reflexive is what? Since each element divides itself, means A divides A. So, for every A belongs to set of natural numbers, A comma A will belong to relation R. So, it is reflexive. Am I clear? Now come to symmetric. Let A divides B implies A implies B by A is going to be some integer. This implies A by B is going to be 1 by K, which does not belong to natural number or integer. That implies B does not divide A. That means B comma A does not belong to relation. See, up to this point, is it okay? Am I clear?
Yes, sir.
So this implies a relation is not symmetric. Correct? Now let's come to transitive. Let A comma B belongs to R and B comma C also belongs to R. Implies what? A divides B and B divides C. Means B is some K times A1 and C is some K times B2. So I can say, sorry, B is some K1 times A and C is some K2 times B. Implies C is some K2 into K1A. Means K1, K2A. This implies C is divisible by A. Or I can say A divides C, or I can say A comma C belongs to relation. Yes or no? You started with AB belongs to R and BC belongs to R, and ultimately you have proved that AC also belongs to R. This implies what? This relation is transitive. Am I clear? Tell me.
Yes, sir.
So now if a relation is reflexive as well as symmetric, reflexive and transitive, but it is not symmetric. So not an equivalence relation. Yes, have a look. Tell me if there is something which you need to know further. Yes, understood everybody?
Yes, sir.
Very good. Now, let's do a question that is there in NCRT. Question is, okay, before that, one or two questions from very general daily life relations. Fine. Say A is a set of all the members of a huge family. A is a set of all the members of a huge family, and a relation R1 is defined as x comma y such that xy belongs to A and x is brother of y. There is a relation R2. I'll leave some space. We'll explain it here only. There is a relation R2 as x comma y, xy belongs to A and x is father of y. There is a relation R3 defined as x comma y, xy belongs to A and x is husband of y. Fine. There is another relation R4 that is x comma y such that xy belongs to A, set A, and x and y live in same house. Now, first of all, let's come to first one. Is this relation reflexive? Tell me. Is this relation reflexive?
No.
No, because no person is brother of himself. Say even in boys we can say, but can a lady call say Neha, can she be brother of herself? No, so not reflexive. Is this relation symmetric? Tell me. Is this relation symmetric?
Yes, sir.
No. If X is brother of Y, it is not necessary that Y is also brother of X. Y can also be sister of X, and if Y is sister of X, she won't be in that relation. Understood? Now, is this relation transitive? Yes. X is brother of Y. If X is brother of Y and Y is brother of Z, then even if Z is a female, X will be a brother of Z also. Correct or wrong? So this will be a transitive relation. Tell me if there is anything which you are not able to understand. X is brother of Y and Y is brother of Z. Sorry, and then X has to be brother of Z. Correct or wrong? Tanush?
Sir.
Now come to father. Is this relation reflexive?
No.
No, sir.
No. No person is father of himself. Is this relation symmetric?
No, sir.
No.
No.
Is this relation transitive?
No, sir.
No. Because if X is father of Y and Y is father of Z, then X is going to be grandfather of Z, not father. So won't be in that relation. Now come to husband. Is this relation reflexive?
No, sir.
No. No person is husband of himself. Is this relation symmetric?
No, sir.
Not again. If X is husband of Y, then Y is wife of X, not husband. Is this relation transitive?
No, sir.
Yes, it will be transitive. Rama,
Sir,
tell me the definition of a relation being transitive. Tell me quickly.
if AB and BC is in relation, then AC also should be in that relation.
And AC you should also belong to relation. If. Now see, let us assume A is husband of Y. A is husband of B. Can B be husband of somebody else further? B is a female. Now B cannot be anybody's husband. Yes or no? So here A comma B will belong to relation, but there won't be any B comma C that belong to relation. Getting my point? So that process of starting to check for transitive has not yet started because there is no AB and BC for which I should look for AC. There is only AB. Getting my point?
Yes, sir.
So that is why this relation is by default transitive. All right. Now, for R4, is this relation reflexive?
Yes, sir.
Yes. Is this relation symmetric?
Yes, sir.
Yes. Is this relation transitive?
Yes, sir.
Yes. Because if XY live in the same house, YZ live in the same house, then XZ also live in the same house. Am I correct?
Yes, sir.
क्या सभी अच्छे बच्चों को मेरी बात समझ में आई? Am I clear? Fine. So these are the examples you will see in NCERT also. Now, let me give you another example from the NCERT itself. And that is a very good relation. A relation R defined on set of real numbers I am denoting real numbers by this symbol. A relation R defined on set of real numbers and R is given as A comma B such that AB belongs to real numbers and A is less than or equal to BQ. ठीक है? Check for a reflexive, symmetric and transitive. Fine. Now, first of all, if you are listening me, listen carefully. 2 comma 3. Does it belong to relation? Tell me. Definitely 2 is less than 3 cube.
Yes.
But 1 by 2 comma 1 by 3. Does it belong to relation?
No, sir.
No. So this kind of examples where see previous example we have proved something because it was a universal truth. Here the relation given, it is sometimes true, sometimes false. So you cannot prove it. The relation is sometimes true, sometimes false. So you cannot prove it. You can only negate it using examples. Like if I check for reflexive, what would you say? Does 1 by 2 comma 1 by 2 belong to relation? If you see 2 comma 2 belong to relation, but 1 by 2, 1 by 2, does it belong to relation? Does not belong to, because 1 by 2 is not less than or equals to 1 by 2 whole cube. Am I correct?
Yes.
Not less than. So, not reflexive. Have I made my point clear? Now let's come to symmetric. See, 2 comma 22. Does it belong to relation? Because 2 is less than 22 whole cube. Am I correct? But 22 comma 2 does not belong to relation as 22 is not less than or equals to 2 cube. Tell me if I'm wrong. Tell me, correct or wrong? Correct. So, not symmetric. Now let's come to transitive. Transitive. See, 100,8 belongs to relation as 100 is less than or equals to 8 cube, and 8,3 also belong to relation as 8 is less than or equal to 3 cube. But 100,3 does not belong to relation as, see, Tanush, I agree your point. You are saying some will be symmetric, but it is not about that. It is some elements are satisfying, some are not satisfying. What it is, even if one element is not satisfying the criteria, I will not say it is symmetric or reflexive. Getting my point? We are looking for shortcomings.
Okay.
Even if you find a single element that does not satisfy the relation, we will conclude according to it. Now, 100,3 does not belong to relation as 100 is not less than or equal to 3 cube. Am I correct? So, not transit. That is why it is not possible to prove it, because these statements are true for some real numbers, are not true for some real numbers. Like if I talk about the reflexive, 2,2 satisfies the relation. 2 is less than 2 cube, but half comma half does not satisfy. Getting my point?
Yes, sir.
That is why we will not call it symmetric, reflexive, and transitive. So since it is not any of the either, it will be a what? Not an equivalence relation. Am I clear?
Yes.
Now I would like to conclude the session. Just let us revise what we have done today. So we started with reflexive types of relation. We started with reflexive relation. So a relation R on set A is called reflexive if its each and every element is related to itself. Even if a single element is not related to itself, out of say 2000, even if a single element is not related to itself, we will call it not reflexive. Correct? Now, I told you the difference between identity relation and reflexive relation. In identity relation, every element should be related to itself only. But in reflexive relation, every element should be related to itself. There can be more elements which are related to this element. Now there comes symmetric relation. Symmetric relation is a relation on set A is called symmetric if AB belongs to R, then BA should also belong to R. Then it will be symmetric relation. All right. Now, in case of transitive, if AB belongs to R and BC belongs to R, then we will look for some AC which belong to R to make this relation transitive. Then we have done an example like A minus B mod is even, which is an equivalence relation. Then we have done an example of A divides B, which is only reflexive and transitive, but not symmetric. Agreed? And then I have given you a proper way how do we write these questions in subjective board exams. Then we have done some family kind of relations, brother, father, husband, as reflexive, symmetric, transitive. And then a question we have done, which is there in NCERT, which we actually cannot prove. We can only comment over the relation by taking some examples, because sometimes the relation given is true, sometimes the relation given is not true. And we are only looking for shortcomings. So there is no concept like, hey, this is little bit symmetric. There's no concept like either it is symmetric or it is not symmetric. It is not like सर थोड़ा सा तो reflexive है, थोड़ा सा तो symmetric है, थोड़ा सा नहीं होता. It is not some portion. Either it is totally symmetric or it is totally not symmetric. Got it? Got it?
Yes, sir.
Now, You guys can complete your NCRT this exercise. This is NCRT exercise 1.1. You complete this exercise. This is totally based on relation kind of questions. Tomorrow we will start with functions. All right.
Okay.
Any other doubt? Anybody? Anything I can help you with? Tell me, tell me, tell me. That's it. All right. Thank you so much. Take care. See you tomorrow.